Lesson 25, Unit 5.3 of the pre-calculus, which is the trigonometry part of pre-cal, is the unit circle. Now, when we talk about the unit circle, we're going to basically start with an XY axis. And when we start with an XY axis and we talk about the unit circle, we're going to be talking about a circle whose radius is equal to 1. So the length of that segment, that radius, would be 1, and you obviously could draw a circle with that radius. Now, what we're going to be dealing with is what happens when you do that. What you do that is that vertical line down, and you could connect it to a horizontal. And if you thought about that horizontal distance and that vertical distance, then you would create a right triangle where the radius is the hypotenuse of that right triangle. If we're talking about an angle in standard position that is formed by that radius and that little green line, the radius then would be the terminal side, and the little green line would be the initial side. So we're talking about an angle in standard position. When we're talking about that, then in this right triangle, then if we x, y, then the red would actually be the value of y at that point, because we just went up from the x-axis that far, right? You could think, well, that distance is y minus y, but the first y is 0. So anything minus 0 is that number. And we could also think of the horizontal move as being x. So our picture of the unit circle, which is what we're going to build a bunch of trig memorization stuff from, is a picture of an angle in standard position with a radius of 1, where the end point of that radius is xy, the x value being the horizontal distance and the y value being the vertical distance. And so we would have a Pythagorean theorem looking thing that would say that x squared plus y squared is equal to your radius squared, correct, in the unit circle. In the unit circle, then, x squared plus y squared, is equal to the radius squared. And we're going to use that to find a lot of pieces and parts. In the last lesson, we talked about sine, cosine, and tangent ratios. Now, what we've done is we define them in terms of leg opposite, leg adjacent. We're going to redefine them in terms of x, y, and r. Okay? So let's talk about that. This angle in standard position, if we call that angle theta, little fish-looking thing, okay? That's alpha, isn't it? I'm sorry. Let's use theta because I'm going to mess up my whole picture. I'll try to put it back in there. Let's talk about an angle theta instead of alpha. I keep trying to mess up my Greek letters. If we let the angle be theta, then we could say, well, the sine of theta is something over something. And the cosine of theta is equal to something over something. And the tangent of theta is something over something. And what we said is sine is leg opposite over hypotenuse, but now we're going to use x and y. According to theta, what is the leg adjacent to theta? I'm sorry, sine, we're doing sine. According to theta, what is the leg opposite theta? The y. And according to that angle theta, what's the radius? R. And so we learn that the sine of an angle in standard position, the sine of an angle in standard position in the unit circle is y over r. And you memorize that for eternity. Maybe not eternity, up to it. Okay? And then the cosine of theta, cosine is the length of the leg adjacent, and the leg adjacent to theta is x. And so cosine theta is x over r. Now, we're going to just use those two for just a second. What's r equal to in the unit circle? Now, I'm putting that on r, right? And if r is equal to 1 in the unit circle, then sine theta is equal to y, because the radius is 1 in the unit circle. And if my radius is 1, then cosine theta is equal to x in the unit circle. So in the unit circle, having an angle in standard position with a radius of 1, we could then say that the x-coordinate of the point is cosine theta, and the y-coordinate of the point is sine theta. And so we're writing the coordinates of the points in terms of trigonometric ratios. Okay? So let's review what we need to memorize. We need to memorize that in the unit circle we're talking about a radius of 1. We're talking about the horizontal distance being x and the vertical distance being y, which creates a right triangle, so we could use the Pythagorean theorem and we could have that x squared plus y squared is equal to radius squared. Knowing that sine is leg opposite over hypotenuse, if we plug in our x, y, and r, we get that sine is y over r, which we memorize that. And if the radius is 1, then it's just y, which means that sine turns into the y-coordinate of the endpoint of the radius when the radius is 1. Cosine is x over r. And when the radius is 1, that means the cosine is x, and so the x-coordinate of the endpoint of the radius of 1 in the unit circle is 1. Okay? Sine is the y-coordinate. So when the radius is 1, then the y-coordinate is sine theta. And we just memorize that, okay? So sine is leg opposite over hypotenuse or y over r. Cosine is leg adjacent over hypotenuse or x over r. Okay, so we're memorizing that. All right, tangent. Tangent theta is leg opposite y over leg adjacent x, y over x. And we memorize that, okay? Now, we know that they have reciprocal functions. What is the reciprocal of, whoops, I put it farther than I wanted. What is the reciprocal of sine? Cosecant. So cosecant would be, if sine is y over r, then cosecant would be r over y, the reciprocal of sine. The reciprocal of cosine is secant. If cosine is x over r, then secant must be r over x. The reciprocal of tangent is cotangent. And so cotangent theta would be the reciprocal of tangent theta, and so it would be x over y. What you're going to find is we can cover a lot of rules, definitions, terms in trigonometry fast. And so within a week, you have this truckload of memory work to do that if you haven't done, all of a sudden you're lost in trig within a week. You have to go home and memorize this as fast as we cover it, okay? If you don't, you'll pay for that. We will have some tests that we don't let you use a calculator on so that we can know that you know your memory work, okay? All right, everybody see how we got that? I'm going to leave these here for just a second, and then we're going to talk about the unit circle, but we're going to have specific angles. So first of all, let's see if we can deal with some crazy stuff. Just to show you where we're going. Let's say that we have the cosine of some angle theta is equal to negative 1/2, and we are in quadrant 2, let's just say. And we want to find all the rest of those. Now, we're getting ahead of the game a little, but I want you to be thinking. Now, we've studied 45, 45, 90, 30, 60, 90 triangles. We've studied that. And you're supposed to just have that in your head just like your first, middle, and last name. Okay, even backwards. Like my name is David Gene Ballard. Backwards, it's Dralau Beneg Devad. That's if you just do all the letters backwards. Now, I'm saying that to say, you know, we talk about please excuse my dear Aunt Sally. Sally, Aunt dear, my excuse, please. Some things we just learn forwards and backwards. Backwards may not make any sense, but we're saying you should be able to memorize to that level. That's what we're trying to tell you. Learn this stuff upside down and backwards. Don't rely on note cards or notes. Rely on your brain, okay? All right, here's what's going to happen for a little bit, and then some of this is going to become memory work. We're going to think, okay, we're in quadrant 2. Now, we wrote this down somewhere, and we'll write it down again. Everything is positive in quadrant 1. Sine is positive in quadrant 2. Tangent is positive in quadrant 3. And cosine is positive in quadrant 4. We've already written that down. In quadrant 1, everything's positive. In quadrant 2, only sine is positive. In quadrant 3, only tangent is positive. In quadrant 4, only cosine is positive. And we're okay because I said that the cosine of something in quadrant 2 is negative, and that's true because the only thing that is positive in quadrant 2 is sine stuff. So cosine stuff is negative in quadrant 2. Now, can we think about the cosine of what is a half? You know when you did the Pythagorean triplets like 3, 4, 5 and you just memorized them because they were real familiar? Or you learned that the square root of 4 is 2 and the square root of 25 is 5 just because you use those a bunch? Well, we're going to learn about 1s and 2s and square roots of 2s and square roots of 3s. Now, why are we going to learn about 1s, 2s, square roots of 2s, and square roots of 3s? Well, because in a 36, 90, the short leg is 1, the hypotenuse is 2, and the long leg is square root of 3. That's that ratio you learned from geometry. And we also learned that in a 45, 45, 90 triangle, the legs are equal, so they're in the ratio of 1 to 1, and the hypotenuse is equal to the length of the leg times the square root of 2. So these numbers, 1, 2, square root 2, and square root 3, are going to pop up in a whole gob of trigonometry problems because they're important. Now let me ask you this. Why would 30, 60, and 45, why would we do those? Just because we like those numbers? They're multiples of 15, so we're like, oh, that's kind of cool. Why would we even be care about 30, 60, 90, and 45, 45, 90? We could have done all of our memory work off of a 40, 50, 90, 20, 70, 90. Why don't we use those? Well, most mathematics is used to construct or build things. If we were to take a square, that's a nice shape we would build stuff out of, and cut it in half, we would get a 45, 45, 90 triangle, right? If we were to build an equilateral triangle, that's 60 degrees. If you draw an altitude, it's 30, 60, 90. If you were to have a hexagon, if you bisect an angle of a hexagon, that's going to be 60. And so the thing is in construction, 30, 60, and 45 kind of pop up a whole bunch. That's why we learn special rules for those and not 20s and 70s. What kind of geometrical shape can you cut an angle in half and get 70? You can't. Not something you're going to build something out of. Okay? If you took an octagon, like stop sign, whoops, I messed that up. There you go. Each angle is 135. You cut that in half and you get 62 and a half. You build that. You don't have really pretty numbers even in an octagon. But what happens if you cut that corner out of a square? If that's 135 degrees, that's 45. The way you make an octagon is you cut 40, 45, 45, 90 triangles off of each corner of a square, and you have a regular octagon. Again, when you get into construction and geometry, you're going to find that these things down here that we're talking about, these 30, 60, 90 triangles and 45, 45, 90 triangles, are very important parts of construction, okay? All right, so we need those in our mind, just like our first, middle, and last name, forwards and backwards, okay? 1, 2, square root 3, 1, 1, square root 2. Now, so let's think about it. We got a 1 and a 2. I'm over here. Cosine theta, negative 1/2. What angle is that? What's the angle theta? Well, cosine is leg adjacent over hypotenuse. I need it so that my leg adjacent's 1 and my hypotenuse is 2. Now, where's that at? Where's your 1 and 2? Right here, leg adjacent, 1. Hypotenuse, 2. My angle's 60 degrees. Now, we got to start thinking this way all the time from now on in trig. Now, we're going to do some memory work, but if you forget your memory work, you're going to rebuild it from this, okay? Eventually, we just want you to say cosine of what's a half 60. Okay, just that fast, just like 3 times 4 is what? 12. But if you don't remember, you can go back and figure it out with your special right triangles. Okay, so we're saying, okay, the cosine of what is negative 1/2? Well, we would say, well, it's 60 degrees. That's my reference angle, right? My reference angle. But we're in quadrant 2. So I'm talking about being in quadrant 2 with a reference angle of 60. So my angle is really 120 degrees. My reference angle is 60 degrees. The real angle we're talking about is 120 degrees. Now, let's say I wanted the sine of that same angle, theta. I want the sine of that same angle. So I want the sine of 120. I'm still going to use the reference angle. So if I'm saying sine of 120, I'm thinking, really, what's the sine of 60? Well, the sine of 60 would be the length of the leg opposite 60 over the hypotenuse. So the sine of 120 degrees, whose reference angle is 60 degrees, would be the leg opposite square root 3 over the hypotenuse 2. But then I got to figure out the sine. Well, what's true about sine in quadrant 2? Sine is positive in quadrant 2, so sine 120 is square root 3 over 2. See what's fixing to start happening? Everything we've learned is fixing to start tying together here. Okay? Now, has anybody got that wants it? Because we're fixing to build a trig table. Over here on my board over here, on the bottom left, there's a trig table, and we're going to start building that trig table. We're going to leave some stuff out of it for a second because we don't know how to deal with it yet. Okay? Is anybody ready for me to wipe that out? You ready? Taryn? Okay. All right, so let's just build a table, and this is important notes. We're going to talk about the angle. Let me reorient. Give me just a second. I'm going to pause. what we're going to do is we're going to fill in this chart based on our special right triangles, because I want you to be able to go back to them to remember this chart in case it leaves you. I've already filled it in red what a radian is, and I'm going to highlight the bottom here. There are 2 pi radians in a circle, and we haven't talked about what a radian is. We know that the circumference of a circle is 2 pi r. When we talk about degrees, we're talking about clicks of rotation. There's 360 clicks of rotation. When we talk about radians, we're talking about a click on the circumference. We're talking length, not degrees. Okay? So a radian is 1 length click around the circle, and there's 2 pi length clicks around the circle. There's 360 degree clicks in a circle, if that makes any sense. We'll talk about that later. We're going to skip the zeros. We're going to go to the special right triangles, 30, 45, and 60 first, and then we'll come back to the quadrantal angles later. Quadrantal angles, remember, when we talk about the x-axis, then 0 degrees would represent horizontal. 90 degrees would represent vertical, so that would be your y-axis going up. 180 degrees would be going to the left on your x-axis. 270 degrees would be going down on your x-axis. And 360 degrees would be where you started, at 0. Those things I have highlighted, the first and last being identical twins, are what we call quadrantal angles. They land on an x or y axis. The rest of these land out in quadrant 1, 2, 3, or 4 somewhere. When we think about sine of 30 degrees, we're thinking about the length of the leg opposite the 30 over the length of the hypotenuse. And if we were looking at our special right triangle right here, and we were talking about leg opposite 30 over hypotenuse, what fraction would you get? Leg opposite 30 is 1. Y'all seeing what I'm talking about? The 30, 60, 90 triangle at the top. I don't want to write on it too much. The leg opposite 30 is 1. The hypotenuse is 2. Leg opposite the 30 is 1. Hypotenuse is 2. So we can memorize forever that the sine of 30 degrees is a half, just like it was a multiplication table. Starting tonight, you're accountable for that forever. Cosine of 30. The cosine of 30 is the leg adjacent to the 30, square root 3 over the hypotenuse 2. The tangent of 30 is equal to the, I'm going to do it down here first, leg opposite 1 over adjacent, square root 3. But you have to rationalize. And so we get the square root of 3 over 3. So tangent 30 is square root 3 over 3. So I could just ask you out of the blue, what's sine 30? Half. Cosine 30, square root 3 over 2. Tangent 30, square root 3 over 3. Just boom, 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 boom. Okay? So we discovered it. Now we are supposed to memorize it. Let's go to 45. I'll do it in green. If we talk about sine 45 is equal to the length of the leg opposite the 45, that's a 1, over the hypotenuse. Sine is leg opposite over hypotenuse, so it's leg opposite 1 over hypotenuse square root 2, but we have to rationalize, and we're going to get square root 2 over 2. So sine 45 is square root 2 over 2. The cosine of 45, well, the leg opposite's the same as the leg adjacent. They're both 1. So sine and cosine of 45 root 2 over 2. The tangent of 45. Tangent of 45 is the length of the leg opposite 1 over the length of the leg adjacent 1. 1 over 1 is 1. So tangent 45 is 1. So from now on we say, okay, what's sine 45? Square root 2 over 2. What's cosine 45? Square root 2 over 2. What's tangent 45? 1. And we memorize it that fast. You got to know it from now on, okay? Now we go to 60 degrees. When we look at the 60, we say sine is the length of the leg opposite the 60, which is square root 3 over the hypotenuse, which is 2. We say that the cosine is the length of the leg adjacent to the 61 over the hypotenuse 2. Cosine 60 is a half. The tangent of 60 is equal to the length of the leg opposite square root 3 over the length of the leg adjacent 1, and square root 3 over 1 is square root 3. So sine 60, square root 3 over 2. Cosine 60, 1 half. Tangent 60, square root 3. You memorize them. Okay? If you look at what we've told you to memorize so far, we've told you to memorize 12 things. That's not that many, really. Multiplication tables is 144, right? If you go through 12 times 12. Of course, there's some doubles. 3 times 4 and 4 times 3 is the same. Anyway, but still we got that. Now we need to go to the quadrantal angles. If you forget those, which we hope you don't, but if you do, you know how to rebuild them. You use your special right triangles to rebuild them. That board over there that's got them written down is going to disappear not too long from now. That was an interesting thing. I don't know how that happened. Isn't that interesting? Do what? Yeah. Who knows? Okay, now let's talk about quadrantal angles. That's the stuff I've got highlighted in green. I want to do a better job than that one. All right. Zero. Now, if I'm talking about 0 degrees, you understand what I've got is you've got that little blue thing. That's your initial side. If we're at 0, where's your terminal side? Same as the initial side. There's 0 degrees. What is R? What's the radius length? 1. What is the length of X? 1. You went to the right one. The radius and the X are the same. They're both 1. You went to the right one. What is Y? How much did you go up or down? None. Okay, so let's talk about 0 degrees in terms of the radius being 1, X being 1, and Y being 0. Remember that sine is, but now we got to talk about X, Y, and R. Sine was Y over R. Cosine was X over R. And tangent was Y over X. Using that information and what you see in the picture, then what would the sine of 0 degrees be? It would be Y, which is 0, over R, which is 1, and 0 divided by any number is 0, and so the sine of 0 is 0. Okay with that? Let's talk about the cosine of 0. The cosine of 0 is X over R. What's the X? 1. What's the R? 1. 1 over 1 is 1. And so cosine of 0 degrees is 1. We're using our X, Y, and R. The tangent. Tangent is y over x. Y is 0. X is 1. 0 divided by 1 is 0. So the tangent of 0 is 0. And guess what we get to do with that one? Add it to our memory list. So from now on, you know sine 0 is 0. Cosine 0 is 1. And tangent 0 is 0. Now we have 15 things to memorize for up to eternity. No trigonometry in eternity, maybe. Anyway, let's look at 90 then. If we look at 90, let me get this out of the way. If I've got 90 degrees, then where did my terminal side end up? Right here. If my terminal side is here, then what is my radius length? Well, it's a unit circle. It's 1. What is x? Did we go left or right? No. What's my y? 1. If I go vertical 90 degrees, then my x is 0, my y is 1, and my r is 1. Everybody see how we're getting that? We're really looking at this point right here, right? Where's that point located? It's located at 0, 1. Now, let's go through this again. Sine. What colors are good? We'll go through, it's time for black. Pi over 2, sine of 90. Sine of 90 is equal to what? Y over r. My y is 1 and my r is 1. And so the sine of 90 is 1. Cosine of 90 is x over r. X is 0, r is 1. 0 divided by 1 is 0. And so the cosine of 90 is 0. Tangent is y over x, which is 1 over 0. 1 over 0. Division by 0 is mathematically undefined. And we say then that the tangent is undefined at 90 degrees. Now, what that's going to look like, just so you know, if we were to graph a tangent and we were to line it out like this, 90 degrees, 180 degrees, what's going to happen is the graph of the tangent's going to look like that, and it's going to be a vertical asymptote, we're going to call it, there. So y is going to just kind of quit. Then there's going to be another one in here, and there's going to be another asymptote. So everywhere it's undefined, the graph just kind of stops. It approaches this vertical asymptote, but it never gets there, and then it continues again on the other side of that. So that's a little place where there's not an answer for tangent. It just drops out. Every 90 degrees, it drops out, okay? It's undefined at that place. All right, now, let's build the rest of this in 3 minutes. The rest is not that bad to build, and I think we can get it done here. Here's the question. If this direction is x equal 1 and y equals 0 and r equal 1, then what is the other direction? X equal -1, y is still 0, and r is still 1 because radius represents a distance. Pythagorean theorem, square root is always positive, right? Distance is always positive. So what's going to happen when you go from the right to the left? It's going to change the sign. So if we already know what the sine of 0 is, to get the sine of 180, all we have to do is change the sign. Same stuff. Okay, so we're going to compare 0 to 180. Now, if the sine of 0 is 0, the negative of 0 is still 0. If the cosine of 0 is 1, see that? If the cosine of 0 is 1, then the cosine of 180 is the negative of that 1, which is negative 1. If the tangent of 0 is 0, the negative of that is still 0. So when you go to we're using 0 as a reference then, right? And when we go across, we're just changing the sign. Now, look at my y's. If I went, instead of up 1, that's 90 degrees. I went down 1, that would be 270 degrees. In that situation, y is negative instead of positive, right? Which still changes the sign. So if I take my 90, I can compare it to my 270, and all I got to do is change my sign. So, what is the sine of 90? 1. So what would the sine of 270 be? Negative 1. The cosine of 90 is 0, the negative of that. The tangent of 90 was 0, was undefined, excuse me. The negative of undefined is still undefined. (360 degrees is the same as 0. It's not like we're going to change the sign. 360 degrees and 0 degrees are the same. So all we're going to do is put in what we had for 0, which is 0, 1, and 0. And so now we have this trig table to commit to memory. Any questions on that? Perfect timing.